As soon as I saw my very first images of the sun, I was just mesmerized. I couldn't believe how much was going on. And then I started hearing about how little we actually knew about the sun. Then I was hooked. I was like, you know, this is something that I really want to try to understand.
The sun is fascinating and very mysterious. To truly understand it, we must attempt the impossible and touch a star. For almost 20 years, NASA and the European Space Agency have been pooling their efforts in order to rise to this challenge. Having landed on a comet with the Rosetta probe, and having caught Pluto on camera with New Horizons, we are finally about to travel to the heart of our solar system.
It is kind of our last place to go and explore, and I would say the most important place for us to go and explore.
With the European Solar Orbiter mission and the American Parker Solar Probe, a 60-year-old dream is about to come true. The notion of solar probes dates back to 1958. And, as is often the case in the history of science, it all began with a revolutionary intuition of a young scientist.
In 1958, a young scientist called Eugene Parker published a paper where he actually predicted that this solar wind, this continually streaming atmosphere away from the sun, would exist.
Young Eugene Parker's discovery was earth-shattering. Without observing a thing, just by using mathematical equations, he worked out that the sun must expel minuscule particles of matter. All the time, and in every direction. This solar wind reaches the whole of the solar system. Eugene Parker changed the way humans view the cosmos forever.
We realized that space wasn't empty, but there were particles streaming full of energy, and so immediately it became clear that to understand this, we probably needed to go close to the sun.
1958 was the start of the space age. Sputnik 1, the first ever satellite, had just been sent into orbit by the Soviets, and the Americans already had some catching up to do. 1958 was a decisive year for the American space mission. Its first breakthrough came in February with the launch of its first satellite, Explorer 1. In July, President Eisenhower created NASA to oversee America's space program. In the wake of the Cold War, the race for a space odyssey began. That same year, scientists from the brand new American Space Agency dreamt up the best possible space missions.
A committee was put together, chaired by John Simpson and James Van Allen, and they were asked to provide guidance and advice to NASA. They came up with 14 missions that they said they're the best things that we could do.
One of the 14 priority missions the Simpson Committee came up with was, of course, a moon landing, which later became the Apollo program. There was also the premise for the Mariner missions, which was to land on Earth's neighboring planets. And another of these 14 projects was the solar mission.
The idea was to go and observe the sun from close up, to get as close as possible to the sun. This mission has been a holy grail for most solar physicists ever since.
We actually have to go there to sample the composition of that atmosphere and the solar wind to fully understand it. And that is important because what happens on the sun impacts us here at the Earth.
13 of the 14 missions dreamt up by the Simpson Committee have become a reality in the ensuing years.
It's one small step for man.
Only one has yet to see the light of day, the solar mission. Engineers have faced an insurmountable challenge: how to build a probe that could withstand such a hostile environment.
So close to the sun, it becomes very, very hot. So it's like being in an oven.
And we are going to be moving through there, working and getting our data. We can't switch off, we can't avoid it. We need to go in there to take our data.
If you had an ordinary material sitting there, it would sort of it would fuse and evaporate very, very quickly.
It has taken 60 years for technological breakthroughs to make the space pioneers' dream a potential reality. To accomplish this feat, engineers from the two missions, Parker Solar Probe and Solar Orbiter, have had to construct super-resistant shields that could withstand the infernal heat. They have rivaled one another in ingenuity, inventing new technology, and sometimes rediscovering materials previously used by cavemen.
We really pushed the boundaries.
It was always designed just at the frontier of what was possible technologically.
It's not just engineers who have been working hard to get close to the sun. This project is finally seeing the light of day, thanks, in part, to the tenacity of solar scientists in Europe and America. Milan Maksimovic has kept the notion of a solar mission in mind for 20 years.
There have been several studies. I myself researched the possibility of a solar probe with Machiavelli. We've been constantly pushing for this mission to take place.
And finally, at the beginning of the years 2000, it seemed that this was actually going to happen. We had a dinner with Milan Maksimovic, whom of course was a good friend of mine back from the days in the observatory in Paris. And we said, well, maybe we are the ones that are actually going to be able to do this and see this mission through.
But scientists soon realized that a single probe would not suffice to solve all the mysteries of the sun. They would need two. First, there was the American Parker Solar Probe. NASA's probe is the closest to what space pioneers envisaged in the 1960s. It was named Parker as a tribute to Eugene Parker, the man whose revolutionary discoveries had inspired the mission 60 years previously could finally contemplate his ideas coming to fruition.
It was a tremendous honor to be able to introduce Gene to the spacecraft, to actually turn to him and say, Parker, meet Parker, and watch just joy and overwhelming come across his face. And he was very gracious. He kind of joked with me, gee, I just wrote a paper.
In his paper, Eugene Parker predicted that a critical zone must exist at a distance of 4 million miles from the surface of the sun in our star's vast atmosphere. This enigmatic region has remained a source of fascination for scientists for 60 years. It is the target of the American probe.
4 million miles, that sounds quite a big distance, but the Earth and the Sun are 93 million miles apart. So if I put the Sun and the Earth on a meter stick, solar probe will be just 4 centimeters away from the surface of the Sun, and that is close.
To get that close to a star without being irredeemably sucked into it, Parker's solar probe would have to be launched into space at considerable speed. NASA has had to come up with a twofold launch, using the most powerful rocket at its disposal, the Delta IV Heavy, with a takeoff thrust of 8 Boeings.
It is an enormous rocket. We need such a big launch vehicle so it can throw us away from the planet.
The secondary rocket is the one that sends it into interplanetary orbit, and will be moving at about 120 miles per second. And it will be by far the fastest spacecraft ever created.
After just 5 months, the American probe will approach our star for the first time. In order to get inside the strategic 4 million mile mark, it will have to keep circling it, getting slightly closer each time round. In December 2024, after a 7-year mission, before it dissolves in the 2 million degree heat, Parker's solar probe will do a final analysis of our star's atmosphere. The NASA probe won't be able to relay images of the sun from a furnace that hot. No telescope would be able to look a star in the eye from that distance without being blinded.
Solar probe will get so close to the sun that at this distance you simply cannot fly a lot of optical instrumentation. So this is something Solar Orbiter will provide.
So it can take images that will prove invaluable for scientists, the European Solar Orbiter probe will have to keep a distance of 26 million miles from the sun. It will need 3.5 years to complete this voyage. The trajectory of Solar Orbiter is very strategic. It will allow us to discover hitherto unexplored territory, in particular the sun's poles.
Solar Orbiter will not be as close to the sun, but its unique orbit, along with its suite of instrumentation, gives a much sort of more global picture of this fundamental physics.
The Solar Orbiter mission will also last 7 years before being abandoned in space. But just like Parker's solar probe, the European probe will have had time to collect essential data that will be transmitted to Earth in just 15 minutes. The results of the two probes will then be coordinated to give scientists around the world a better understanding of our star.
For us, this is a golden opportunity to have the two missions up at the same time and working together. The missions are very similar in what we want to do, but the methods that we're using to do it are very different.
One technical element in particular will be very different in the two missions. The heat shield situated at the front of the probe. That is the key to the mission, but also the main obstacle engineers have been coming up against since the 1960s.
If the heat shield fails in any way, then the inside of the spacecraft is going to start to heat up. And our instrument and our satellite, if it gets too hot, then they will just stop working.
The slightest fault in the heat shield would signal the end of the mission. For each of these two probes, the engineers have had very different issues to overcome. For Parker's solar probe, they have had to create an ultra-reflective shield that would survive being closer to the Sun than ever before. The European Solar Orbiter probe will get a bit less hot, but its shield must be ultra-fine so that it can be pierced to make openings for the instruments without it being weakened in any way.
You protect very well and then you leave a small leak and this destroys the isolation.
In Turin, the aerospace manufacturer Thales Alenia Space has taken 6 years to perfect the heat shield for the European Solar Orbiter mission.
Electronics are a bit like human beings. They work well at an ambient temperature of somewhere between 20 and 50 degrees centigrade. We have had to produce a shield that is just a few centimeters thick to protect our instrument from this intense heat. It's been a big challenge.
The engineers for Solar Orbiter spent a long time selecting materials capable of withstanding such an inferno. They have an exceptional instrument at their disposal for test purposes, a sun simulator. The exact conditions for the mission are reproduced in this tank. Firstly, the void, but also, more importantly, the heat and solar radiation. Before being selected, each material is tested to see if it is fireproof.
We make sure they don't disintegrate at high temperature. So we do a lot of sample testing of these materials in small quantities. And from that, we extrapolate then the properties of the big surfaces on the spacecraft.
We tested the sample, failed, changed the material, failed again, made another sample, and this time was successful and selected.
In 2012, a solution was finally found for the European Solar Orbiter mission. Its shield is formed of two large panels, each measuring 2 meters by 3, placed 20 centimeters apart. The front panel is composed of 20 very fine layers of titanium. The back panel is made of carbon fibers. The titanium structure reflects some of the intensity of the sun's rays into space. The rest hits the second panel. The heat bounces between the shield's two panels before being expelled into space through the side openings. To make it even more effective, a unique covering has been created especially for the mission. It's called Solar Black. And against all expectations, the engineers had recourse to a pigment previously used by cavemen.
Solar Black is made from burnt bone charcoal. Interestingly, this is the same type of material that prehistoric man used to paint on the walls of caves. And this is a really stable substance. It won't be oxidized. It will still be pristine at the end of the mission as it is at the beginning.
Parker's solar probe shield is quite different from that of its European counterpart, because the thermic challenges faced were even greater. The American probe will dive into an atmosphere that reaches temperatures of 2 million degrees, and it will get closer to these powerful solar flares than ever before. But at 2 million degrees, no metal can remain solid. The mission is only achievable because the sun's atmosphere is very unusual, quite different to anything ever experienced on Earth.
The sun looks like fire and it looks like there's lava coming out of the sun, but in fact, it's not exactly that. It's not like a bunch of material. And actually, at that point, the atmosphere and the corona and the material that's flying away from the corona is actually not very dense. So there aren't very many particles.
The sun's atmosphere is billions of times denser than the Earth's atmosphere. The particles there are extremely hot, but they are also far too small and widely dispersed to burn the probe. The real risk for the Parker Solar Probe is the sun's rays, like the ones which warm us on Earth. But at that distance, the rays are 700 times more powerful than they are here. The temperature of the shield will rise to 1,400 degrees. That's cooler than 2 million degrees, but it's still intense.
1,400 degrees is already hotter than the melting point of most materials. The ovens you get in kitchens today reach a maximum temperature of 300 degrees. So where we're going to be sending our instruments is really extremely hot.
To find a material which can withstand 1,400 degrees Celsius, the American probe's engineers took their inspiration from space shuttles.